Vanakkam. Welcome to this course on classics in neuroscience. We have been looking at classic Nobel Prize winning works. In this series, we will look at the classic Nobel Prize winning works of Hodgkin and Huxley. In this video, we will look at how Hodgkin and Huxley met and the challenges they faced in performing their research, the state of the field of neuroscience, neurophysiology and electrophysiology before Hodgkin and Huxley came into the picture, and the theories that existed before Hodgkin and Huxley, and what happened with the experiments and the studies of Hodgkin and Huxley, and essentially trying to set the background of what was the state before and what was the state after, so that we can know what was essentially their contribution. So, Hodgkin and Huxley met at the University of Cambridge during the late 1930s. They were both absolutely obsessed in understanding the biophysics of the neuronal cell membrane or nerve impulses. So, they worked very intensively together on nerve physiology and the experiments on nerve physiology. What are the problems that they faced? They had many challenges that are not faced by today's neurophysiologists, electrophysiologists, neuroscientists, for example. In the good old days, there was a lack of accurate instruments to measure ionic currents. Despite the significant contributions made by stalwarts and legends like Sherrington, Adrian, who are the others? Alexander Forbes, who are the others? Gasser and Erlanger. Despite all their contributions, the methods still did not have the accuracy that you needed to describe what happens within a neuron, what happens at the membrane potential level. That kind of resolution, despite all the contributions by all these Nobel laureates, not all of them are Nobel laureates, Sherrington is Nobel laureate, Adrian is Nobel laureate, Gasser and Erlanger Nobel laureates, but not Alexander Forbes. Despite the brilliant contributions of all these legends, still you lacked the sensitivity and the resolution to measure from individual axons or the membrane potential across the plasma membrane of individual neuronal cells. There were many problems. Other than that, there was also a difficulty in isolating and maintaining individual neuronal cells, because many of these are really small, and in the good old days you really did not have methods to isolate a neuronal cell without damaging it permanently. So, there were many challenges in terms of the physiological or the surgical and the experimental approach towards isolating and maintaining the neuronal cell in such a way that it will still function, that it will not die. There was practically very limited understanding of membrane potential and the dynamics of membrane potentials by the time Hodgkin and Huxley came into the picture. What were the theories? Most of the theories of neuronal conduction were speculative at best. So, perhaps this is how it happens. Those are all stories. For science, you need evidence. Evidence means numbers, data, convincing data, and all these theories essentially lacked quantitative or data based support. So, most of these were stories, and they were brilliant stories, to give credit where it is due. They were quite insightful, but in science you cannot believe stories, you need evidence, you need data. There was practically very little understood about how does communication happens within a neuron. Action potentials were all speculative, but what are the mechanisms by which this communication happens? These ionic mechanisms, very little understanding. Existing theories could not really explain the consistency or the repeatability or the stereotypical data, stereotypical nature of this action potentials and the speed at which it happens could not be explained by the existent theories of the time. What were these theories? What was the theories before? As early as 1887, a good 30 years before the birth of Huxley, already some things were known. For example, dissociation of salt into ions, osmosis on solutions, Arrhenius theory of dilution, Arrhenius theory of dissociation of salt into ions, osmosis on solutions, Van Hoff's theory were all already known. Nernst equation was already known in 1897, essentially describing the relationship between concentration of solutions across a semi-permeable membrane. These details I teach in my other course on neuroscience of human movements. Please do check that, where I describe how this equation is derived and the details beyond the scope of this course. Also in 1902, a brilliant hypothesis by Bernstein, and he suggested that the communication happens probably due to changes in the concentration or the permeability or the conductance of the membranes to specific ions. It's a very insightful, brilliant theory, but no data to back it up. So, the modern era of experimental neurophysiology or electrophysiology was practically invented by Hodgkin and Huxley, which is when they started in 1930s, late 1930s their work on this. Until then, many of these remained stories and unsubstantiated theories. With this, we come to the end of this video. In this video, we looked at the meeting of brilliant minds of Hodgkin and Huxley and the challenges they faced in terms of difficulty of accurate measurements, poor resolution, and the state of neuroscience theory and experimental practice before the advent of Hodgkin and Huxley. And with this, we come to the end of this video. Thank you for your attention.